Welcome to Physics 2048. This video provides background information that I provide only on the first day of class. So it's particularly important if you missed the first day of class or the first part of the first day of class when I went over this information. If any part of it isn't clear to you, be sure to contact me during my office hours or before or after class so you can get those things clarified. That also applies to any questions you might have about the syllabus. First, the most important announcement is that lab meets this week. And when you come to lab, you'll need to bring a calculator because we will be doing things in the lab this week. Next, in no particular order, but perhaps the most important part of these announcements is that you be in the correct class. This is a calculus-based physics class that's intended for engineering majors, as well as students majoring in physics and the other physical sciences. That includes biochemistry, but it does not, I repeat, does not include biology, does not include architecture or pharmacy. Most of the students taking this class are engineering majors. All of the examples will therefore come from engineering, as well as basic physics that people who plan to take, say, physics major classes or chemistry major classes need to know. This class is not for pre-med biology majors. It's also not for people who plan to major in architecture or pharmacy. You may need to take this class if you're planning to major in pharmacy and have biochemistry as your backup major when and if you do not get into pharmacy school. Otherwise, those majors, biology, pharmacy, and architecture, should be taking Physics 1053 rather than this course. Our textbooks assume that you've already learned basic SI units in a chemistry class because majors that require physics generally also require chemistry. If you don't know these, you'll need to learn them on your own from the textbook. Other books and examples in class, although there are also some examples in a video that I've made to help you with learning how to use units in this course. That also applies to details like moles that are normally taught in chemistry and are occasionally used in physics. The most important thing we expect you to know is algebra and trig. Enough algebra and trig to be able to pass calculus without a whole lot of difficulty. If you've already passed Calc 1, you probably know enough algebra to do okay in this class, but you need to be ready to do at least 10 hours a week of homework in calculus and 10 hours a week in physics because of the lab reports, but also just to keep up every day in class. You should be planning to do at least an hour, if not 2 hours of homework every day of the week. In particular, I want to warn people that if you struggled to pass trig or pre-calc, or if you really struggled in Calc 1, you probably should not take calculus and physics at the same time. It's hard enough to learn problem solving and all of the physics you need to learn without also having to learn algebra and calculus at the same time. Another important announcement involves calculators. I will not allow you to use a TI-83 on exams. That means you should acquire and use regularly a standard scientific calculator of the type that's generally referred to as a two-line calculator. A few of the common names are listed here on the screen, but I'll emphasize that the real details are on the website for this course. You can find information about it on Canvas as well. This applies not just to graphing calculators of the TI-83, but any calculator that can store text or symbolic equations or do symbolic algebra. I will add, however, that the advantage of the more basic scientific calculators over a math calculator is you can always tell if it's in degree mode, and it is usually much better designed to use scientific notation. That's true in particular for several of the calculators on my list. I want to remind you that you should be using this physics calculator for all of your homework problems. Bring it to class every day and use it when we work problems in class. Reserve your TI-83 for your math classes. Other important information is on Canvas. That includes the full 7-page syllabus and a few other things like the advice I give you that was provided by former physics students. I only hand out a short one-page version of the syllabus that also includes a calendar for the course. Everything else is on Canvas. You should pay particular attention to the grading rubric that's used on exams, as well as some of the details about using ln kappa. The advice from former students is perhaps even more valuable. They took a lot of time to explain what they learned about learning physics when they took Physics 2048 last semester or semester before. One thing boggles my mind is how important they think it is to read the book. Faculty will always tell you to read the book before class, maybe do homework before it's due, but students have learned that the hard way in this class and will generally give you that kind of advice. You'll see also a number of other very good suggestions for how to study for this class and how to approach every class every day. And some even remind you to read the syllabus, so go read it now. Before I get into any final details, I want to warn everyone taking this class that if you're planning to be an engineering or a science major, you need to approach this course very seriously. It's foundational material for physics and chemistry and engineering majors. People expect you to pass these kinds of classes like Physics 2048 and Chemistry 1045, the very first time you take them because they're easier than the kinds of classes you take as an engineer. Every engineering school requires the same courses, and each one has a way to keep out students who are not prepared to become engineers. At FAMU FSU College of Engineering, you get only one failing grade, that is one D or F grade in the 4 core classes that they look at. They do, however, ignore withdrawals. That means that if you're in trouble in either physics or calculus, you should withdraw rather than risk failing. You can't afford to have 2 failing grades on your transcript in those classes if your only objective in life is to go to Florida State University or FAMU for engineering. Other colleges don't have this requirement, but they might count W grades as attempts or require a minimum GPA. And in addition, if you're planning to major in one of the sciences at Florida State, they count failing grades in every course required for their major, so that would probably include this class if you're taking it. We use an online program called Law and Kappa to do homework. I won't say much about it here except to point out that I will have or have already demonstrated how to use it in class. If you've missed any of those, be sure to pay attention to the next time I do that in class or contact me or some other student in class for help on that. You do need to start doing that first homework set today. Your username is the same as that for email. If your username is Smith123, it's the same here. No extra stuff afterwards. All letters in lowercase. The password is different from what you use for email and Passport at TCC. I'll say that again. Your password is different than you use for other things at TCC. I won't say what it is. That's explained in class and provided in the syllabus on Canvas. If for some reason you forgot your password or it doesn't work for you, send me an email from your TCC account and I'll deal with it. So log in and get started today so that you know if everything is working for you. So start your homework. Part of that is to review the syllabus and the advice files that are on Canvas. Log into Law and Kappa so you know how that works and do the first couple of problems. They're very simple problems. And finally, read the IDEA approach that's on page 8 of our textbook. That is the foundation of how we will do problems all semester in this course and in the next one. And finally, start learning the equations we use. Some of those are given in the next video.